Mic check. Yeah. Good evening everyone. This is Dr. Abhijeet, Faculty of Anatomy and Biochemistry. And today I'm going to discuss part 4 in biochemistry today. That is the biochemistry of carbohydrates. Okay, that is part 4. And today I will be discussing about the oxidation part of monosaccharides. Okay. So yeah, I'll just start with another 1 minute, one more minute, and then yeah. So yes, firstly I'll make a list of what all topics that we have already discussed. What all topics that I have already discussed. Yeah. Vipin, good evening. Welcome to the session on biochemistry of carbohydrates. Yeah. Welcome, welcome. I'll just start. Yeah. Good evening, good evening. Just one more minute and then I'll start with the class. Okay. Sheikh Taha, hello. Welcome Nishant, good evening. Yeah, good evening, good evening, good evening guys. Chal. So yeah, Nishant, good evening. So today I will be focusing. Now what all topics we have already discussed guys. You already know I have discussed the introduction to biochemistry. I have discussed monosaccharides. I have discussed monosaccharides. I have discussed disaccharides. I have discussed polysaccharides. Okay, I have discussed polysaccharides. I have discussed the ring structures. Everything I have just discussed with you people. Okay, good evening Siddhi. Ring structures. Okay, disaccharides also, the bonds, everything is being discussed. Okay, now I have started with oxidation. Now I have started with the oxidation part. Okay, we are discussing carbohydrates. We are discussing carbohydrates, and carbohydrates I have already discussed these topics. Now I will be focusing on the oxidation part. Rimsha, good evening. Yeah. So yes. So yesterday I have discussed the oxidation, that is the mild oxidation. Okay, I have discussed mild oxidation where carbon atom, where the first carbon, okay, carbon 1 was oxidized. Now I am taking a second case. Now I am taking a second case. Anushka, good evening beta. Now I am taking a second case. Yes, I am taking a second case where carbon atom 6 is oxidized. Okay, C6, or if the sixth carbon atom is oxidized. Yesterday I discussed where the first carbon atom was oxidized. Now I am discussing where the carbon 6th of glucose is oxidized. Okay, is oxidized. So yes, now see, we already know we have 6 carbons. We have 6 carbons. Okay, numbering them from 1 to 6. Numbering them from 1 to 6. You already know we are drawing the structure of glucose and we are watching the oxidation of sugars. Okay, in oxidation of sugars, फटाफट से बता दो कि अगर एल्डिहाइड को ऑक्सीडाइज करोगे तो क्या बनेगा. In the chat box everyone, I want the answers. When you oxidize an aldehyde group in the sugar molecule, in the glucose molecule, what is the product that you will get? In the chat box I want the answers. Beyond that I'll just complete the structure. Hazira, good evening. Hazira, good evening, beta. Welcome to the session. Yes. Now you already know that we have an aldehyde group at the first carbon. Okay, we have an aldehyde group, that is the CHO group, which is present at the first carbon. Okay, apart from that, yes, it is carboxylic acid. Very good, Siddhi. It is carboxylic acid. So you already know कि second carbon पे, fourth carbon पे और fifth carbon पे OH यहाँ होगा और third carbon पे OH जो है that is on the left hand side. ये right side ले लेते हैं, ये left hand side ले लेते हैं. Okay, yes. निशांत, वेरी गुड बेटा. और बाकी सब जगह H हाइड्रोजन बैलेंस करने के लिए लगा दिया. ठीक है, सो दिस इज द सिंपल स्ट्रक्चर. और लास्ट में आपको पता है व्हाट इज देयर, इट इज यस CH2OH. नाउ आई एम सेइंग कार्बन 6 इज गोइंग टू, या हजीरा, अनुष्का, perfect बेटा. नाउ आई एम सेइंग कार्बन 6 टू बी ऑक्सीडाइज्ड. नाउ व्हाट विल हैपन, this carbon 6, when it will oxidize, okay, when it will oxidize, what will happen, hydrogen molecule will be removed and there will be addition of an oxygen. Hydrogen will be removed and there will be an addition of an oxygen molecule. Okay, now what will happen if we simply write that carbon 6 is oxidized, carbon 6 is oxidized, what will happen, we have yeah, we'll draw the same structure again beta, that is 1 2 3 4 5 and 6. Now this carbon will contain an acid group over here. Okay, this will become acid because we have already removed this H2. Okay, and we have added oxygen over here. We have added oxygen over here. So yes, yeah, we have added oxygen over here. So yes, this structure, okay, where the sixth carbon is containing a carboxylic acid group, it is known as uronic acid. Write down this structure, it is known as uronic acid. Uronic acid. मुझे फटाफट से जो कल मैंने आप लोगों को पढ़ाया था कि अगर फर्स्ट कार्बन एटम ऑक्सीडाइज होता है तो उसका प्रोडक्ट क्या होगा. आई वांट द आंसर्स. कि फर्स्ट कार्बन एटम जो ऑक्सीडाइज होगा उसका प्रोडक्ट क्या होगा. वेयर एज कमिंग ऑन टू द सिक्स्थ कार्बन एटम, उसका प्रोडक्ट तो मैंने आप लोग को बता दिया, दैट इज द यूरोनिक एसिड. दैट इज द यूरोनिक एसिड. आई हैव ऑलरेडी टोल्ड यू दैट इज द यूरोनिक एसिड. Yeah, that is the uronic acid. Sure. Sir, are you going to teach us at Avicenna? पता नहीं, no information yet. I'm waiting a call from every university now. I'm so much free nowadays. I can come anywhere. Okay, so I want the answers from you people कि अगर sixth carbon oxidize हो रहा है तो यूरोनिक एसिड है. What about when the first carbon was oxidized? मुझे इसका आंसर नहीं मिला, किसी ने इसका आंसर नहीं दिया अभी तक. चलो, वेरी गुड. आई एम वेटिंग फॉर द आंसर्स. वेयर एज yeah, now this COH is basically the uronic acid. Okay, and since it is a part of the glucose, remember it is the glucuronic acid. It is the glucuronic acid. I hope you guys are all like listening to me. Okay, so yes, so it is the glucuronic acid. Remember, glucuronic acid. What is the clinical significance of this glucuronic acid? It is participating in the conjugation of bilirubin. We will learn this in pathology. It participates in the conjugation of bilirubin and Second most, it is involved in the synthesis, gluconic acid. Yes. And it is involved in the synthesis of glycosaminoglycans. It is involved in the synthesis of glycosaminoglycans, also known as proteoglycans. इसको हम लोग proteoglycans भी बोलते हैं, that I will discuss in the next class. Proteoglycans, glycosaminoglycans क्या होते हैं, that I will definitely discuss in the next class. Okay. So till now, write that we have two clinical significance. One is the conjugation of bilirubin, and other one it is the synthesis of glycosaminoglycans or proteoglycans. Okay. Apart from that, coming on to the next case, write down the next case. हमने फर्स्ट केस में देखा कि कार्बन 1 ऑक्सीडाइज हुआ, सेकेंड केस भी सॉ कि कार्बन 6 इज ऑक्सीडाइज्ड, और दोनों माइल्ड ऑक्सीडेशन थे, Now I am telling that if both carbon 1 and carbon 6 is oxidized, if both carbon 1 and carbon 6 is oxidized, what will happen? You already know कि we have now first try to draw the structure of the glucose. I hope you will be able to draw up till now on your own. Okay, Jinesh, welcome to the session. I hope you will be able to draw up till now. You all are aware that at first place we have the aldehyde group, that is the CHO group, and at last we have the hydrogen and the OH group over here. Okay, whereas all other carbons you already know कि second carbon, fourth carbon and fifth carbon, we have the OH on the right side, and on the left side at third carbon we have the OH group, right? Whereas the balancing hydrogen you will put simultaneously, right? So this is a normal state chain structure of glucose. This is the structure of glucose. Now I am taking a case where both carbon 1 and carbon 6, this carbon and this carbon, oxidized. If both carbon 1 and carbon 6 is oxidized, Jinesh, good evening. If both the carbons are oxidized, you already know this is the first carbon, second, third, fourth, fifth and sixth. Now I'm taking a case where both the carbons are oxidized, and you already know what is the product that you will get. Both will convert into carboxylic acid. Both will convert into carboxylic acid. So yes, we have 6 carbons, and at the first position it will change into COH, that is the carboxylic acid, and also at the 6th position it will again change into COH. Rest all structure remains same. Rest all structure remains the same. Okay, so yes, rest all structure remains the same. You can very well see कि if both carbon 1 and carbon 6 are oxidized, it will result in a compound that is called as saccharic acid. It will result in a compound that is called as saccharic acid. Now, if we are taking the glucose, okay, so write down. In case of yes, Hazira, very good. It is COH, very perfectly told. It is, I've already told कि COH group है, first position पे भी COH आएगा और last पे भी. So that particular compound, it is known as saccharic acid. Now if we are talking about glucose, so in case of glucose, you very well know what will it will form? Glucosaccharic acid, because we have saccharic is the compound, okay, and it is glucose, so we are adding glucose, okay, so it will form glucosaccharic acid, okay, and in case of galactose, it will form galactosaccharic acid. Okay, galactosaccharic acid. Okay, Vashvi, you are late. Vidhi, you are late. It's already 13 minutes, 15 minutes. I just started with the session. Yeah. Anyways, remember guys, remember guys, this galactosaccharic acid, it is known as mucic acid. Okay. And what is the clinical significance? The clinical significance, it is a test which is very commonly known as mucic, Nazi, good evening, mucic acid test, and it is referred to as the test for glucose, the test for glucose. What is glucaric acid? Test for glucose, and it is done in patients who are suffering from galactosemia. It is done in patients who are suffering from galactosemia. It is done in patients who are suffering from galactosemia. So just give me a thumbs up guys. You already have done this, I suppose. Yeah, just give me a thumbs up. That you have already done. Okay. Okay, just give me a thumbs up. अच्छा, Hasira has asked me a question. ओके, ग्लूकारिक एसिड तो बच्चे की मैंने लिखवाया ना अभी आपको, सैक्रिक एसिड, इसी को ग्लूकारिक एसिड भी बोलते हैं बेटा. ओके, जस्ट राइट इट डाउन ना. हाँ, हेलो सर, मैं क्लास ले रहा हूँ यूट्यूब पे ना, मैं आपको बाद में बात करूँगा आपसे. ठीक. चल, perfect, perfect Nishant, perfect Nisi, perfect. So that was about the clinical significance, that is the mucic acid test, that is the galactosaccharic acid. Basically we are testing for the glucose over here in patients of galactosemia. Okay, we are testing for the patients of glucose in galactosemia. Now guys, we have already discussed about the oxidation part. First was mild oxidation of carbon 1. Second was mild oxidation of carbon 6, that is glucuronic acid product. Both if C1 and C6 is oxidized, then you have saccharic acid. In case of glucose, it will be glucosaccharic acid. In case of galactose, it will be galactosaccharic acid. In case of galactose, it will be galactosaccharic acid. Now coming on to the next part, that is the reduction. Now coming on to the next part, that is the reduction. Now remember that I told you whenever like any part is reduced, what is the product that it will form? Oxidize होने पर क्या बनता था? Acid. और reduce होने पर क्या बनेगा? Anyone can let me know? So you already know the basic concept. If any monosaccharide is reduced, it will form alcohol. It will form alcohol. So remember, we will just write it over here that if glucose is reduced, it will form sorbitol. It will form sorbitol. And what is the clinical significance? Clinical significance of this is basically it leads to a condition that is called as diabetic cataract. Okay, diabetic cataract. Okay, and to reduce glucose into sorbitol, an enzyme is used over here that is called as aldose reductase. That is called as aldose reductase. Okay, that is called as aldose reductase. So this enzyme basically converts glucose into sorbitol. Okay, sure. Now, okay, एक क्वेश्चन और लिख लेना, that which pathway or pathway which produces sorbitol in our body is sorbitol pathway or polyol pathway. Okay, pathway which produces sorbitol in our body, it is basically sorbitol pathway or polyol pathway. Okay, now coming on to the next part, that if suppose the galactose is reduced, it will form alcohol, that is very well known, and the alcohol it will form, it will be galactylol. Okay, or we commonly call it as dulcitol. It is actually seen in patients. Okay, or it leads to the development of cataract in galactosemic patients. Development of cataract in galactosemia. Cataract is called as mannitol. Okay, that is the clinical significance. And at last, remember, we have the fructose. Okay, you already know fructose is a ketose. Okay, so yeah, it will result in formation of two alcohols. It will result in formation of two alcohols. One is sorbitol, okay, and the other one is mannitol. Other one is mannitol. Okay, so fructose is basically a ketose sugar, and it will lead to the formation of two alcohols, that is sorbitol and mannitol. That is sorbitol and mannitol. So that was a very short like about the reduction, about the oxidation that we have discussed. Only this is something which you have to learn and revise. Now I will be starting with a very new topic, that is called as the isomerism in carbohydrates. Up till now I have discussed in introduction to biochemistry or biochemistry of carbohydrates, I have discussed all that parts, monosaccharides, disaccharides, polysaccharides, all the compounds are discussed with structures, with reactions, everything. Oxidation and reduction of monosaccharides is done. Now I'm starting a very new topic in carbohydrates, that is simply isomerism in carbohydrates. That is simply isomerism in carbohydrates. Isomerism in carbohydrates. Now see, isomerism is basically of two types. Isomerism is basically, this is a new topic in carbohydrates. Okay, this is a new topic. Isomerism is basically of two types, that is structural isomerism, or stereoisomerism, also called as the stereoisomerism or structural isomerism, and the other one it is called as the optical isomerism. optical isomerism. Okay, so remember, what do you understand by the structural isomerism is simply that it has same molecular formula, and different structural form, Okay, structural isomerism simply means that it has same molecular formula and different structural form. And when we talk about optical isomerism, it is the difference. Yes, Nishant, you are very much right. It is the difference in rotation of plane polarized light. It is the difference in rotation of plane polarized light. So yes, it is the difference in rotation of plane polarized light. Now coming on to a term, first let us understand what do you mean by an asymmetric carbon atom. हम बार बार asymmetric carbon बोलते हैं, अब इसको समझते हैं कि asymmetric carbon atom का मतलब क्या होता है. What do you understand by the term asymmetric carbon atom? Yeah, plane polarized light, that is the PP light. Very good Nishant. Yeah, perfect अनुष्का. तो अब इसमें आप लोग को पता है कार्बन की 4 वैलेंसीज होती है. We have 4 different valencies of carbon. You already know we have 4 different valencies of carbon. Now these 4 valencies, okay, अगर ये चारों की चारों पे different ग्रुप्स लगे हुए हैं, ठीक है, एक पे कोई ग्रुप लगा हुआ है, एक पे कोई ग्रुप लगा हुआ है, अगर ये सेम होती, हाइड्रोजन लगा होता सब जगह, तो ये एसिमेट्रिक नहीं होता. एसिमेट्रिक की डेफिनेशन सिंपली ये बोलती है कि कार्बन की चारों वैलेंसीज जो हैं वो डिफरेंट होंगी. कार्बन की चारों वैलेंसीज क्या होंगी? डिफरेंट होंगी. मींस दे आर ऑक्यूपाइड बाय डिफरेंट काइंड्स ऑफ ग्रुप. ओके, सो बेसिकली दिस कार्बन इज सराउंडेड बाय 4 different groups. It is surrounded by 4 different kinds of group. Okay, and this is called as the asymmetric carbon atom. This is called as the asymmetric carbon atom. Okay, this is called as the asymmetric carbon atom. Now guys, remember we have, now let us just take the example of glucose and understand this isomerism. Okay, so you already know we have 6 carbons, and now I will try to explain all this. Okay, just try to listen. Okay, we have CH2OH over here. Okay, we have the aldehyde group in the first place. Okay, we have the aldehyde group in the first place. The OH group is basically present. Yes, chiral carbon. Very good, perfect beta, Anushka, Nishant, perfect. So you already know कि at second position, okay, second position, fourth position, and the fifth position, the OH is present on the right hand side. Whereas when we talk about the left hand side, so it is present over here. Okay, the OH will be here and H will be here. So you already know this particular structure. Now coming on to the fact, क्या फर्स्ट वाला कार्बन, अगर हम फर्स्ट कार्बन की बात करें, क्या ये एसिमेट्रिक कार्बन हो सकता है? नो, वाई नो? क्योंकि एक ग्रुप तो देखो ये हो गया, 2 ऑक्सीजन हो गए ना, तो यहाँ पे तो 2 ऑक्सीजन वाला एक पार्ट आ गया और एक तीसरा ये वाला पार्ट आ गया, तो इस कार्बन पे 2 ऑक्सीजन तो सेम जैसे आ गए, तो फर्स्ट वाला एसिमेट्रिक नहीं होगा, चारों की चारों डिफरेंट होनी चाहिए। अगेन आई एम रिपीटिंग द डेफिनेशन, ऑल 4 पार्ट्स शुड बी डिफरेंट। नाउ कमिंग ऑन टू द सेकेंड कार्बन। सेकेंड कार्बन पे देखो, सेकेंड कार्बन पे ये वाला ग्रुप लगा हुआ है, ठीक है, सेकेंड कार्बन पे ये वाला ग्रुप लगा हुआ है, ये फर्स्ट, चारों वैलेंसीज देखते हैं, ये सेकेंड, ये थर्ड, और इस कार्बन पे ये फोर्थ वाला पार्ट अटैच्ड है। तो अब ये 4 वैलेंसीज देखो इसकी, इस सेकेंड वाले कार्बन की चारों डिफरेंट है, ये चारों की चारों डिफरेंट है। सो बेसिकली हम लोग क्या बोल सकते हैं कि सेकेंड कार्बन इज सराउंडेड बाय, yes, perfect, it is surrounded by 4 different valence group, it is surrounded by 4 different valence groups, okay, that's why C2, the second carbon, it is basically an asymmetric carbon atom, it is basically an asymmetric carbon atom। उसी तरीके से आप C3 लोगे, C4 लोगे, C5 लोगे, तो C3, C4, C5, these all are asymmetric carbon atoms, okay, these all are asymmetric carbon atoms। now can anyone tell me कि sixth asymmetric carbon atom क्यों नहीं होगा? सिक्स्थ एसिमेट्रिक कार्बन एटम क्यों नहीं होगा? आपको फिर CH2OH को कैसे लिख सकते हो बेटा, फटाफट से मुझे बता दो। CH2OH को हम लोग सिंपली क्या लिख सकते हैं? OH ऐसे लिख दिया और हाइड्रोजन को इस तरीके से बना दिया, तो ये इन शॉर्ट फॉर्म किसका है? CH2OH है। तो अब खुद देखो, एक ही कार्बन के 2 वैलेंसी तो सेम ही आ रही है ना, हाइड्रोजन हाइड्रोजन, तो सिक्स्थ वाला जो है एसिमेट्रिक कार्बन एटम नहीं होगा, तो सिक्स्थ वाला एसिमेट्रिक कार्बन एटम नहीं होगा। ओके, सो रिमेंबर दैट इन स्ट्रेट चेन, in straight chain of glucose, और ये क्वेश्चन एग्जाम में बार बार पूछा गया है। yes, it has 2 hydrogen atoms, very good अनुष्का, very good निशांत, perfect, yes, in straight chain of glucose basically we have 4 asymmetric carbon atoms, 4 asymmetric carbon atoms, 4 asymmetric carbon atoms, that is C2, C3, C4, C5. We have 4 asymmetric carbon atoms, that is C2, C3, C4, C5. Okay, we have 4 asymmetric carbon atoms, that is C2, C3, C4 and C5. So I hope now write down a note now. I hope this is understood to each and everyone. बच्चे, just give me a thumbs up that you all like understood. Yeah, you all understood whatever I have explained up till now. कि yeah, just give me a thumbs up that you all have understood so that I can really switch on to the next part. Yeah, Nishant, Hazira, perfect beta, perfect. चल ठीक है, निशांत एंड हजीरा participating, very good. I don't know why others are not answering. Yeah, Anushka, it's okay, good. बाकी सो रहे हैं, पता ही नहीं है क्लास चल रही है, हो रहा है कुछ पढ़ाई, ठीक है, पढ़ लो। एट लास्ट आपको ही दिक्कत होगी, बाद में इतनी बड़ी बड़ी रिएक्शंस आती हैं, ग्लाइकोलिसिस वगैरह पढ़ोगे, अभी बेसिक चीज़ें नहीं समझ में आएंगी तो फिर बाद में दिक्कत होती है और फिर वो एक दिन में याद भी नहीं होती। फिर बायोकेमिस्ट्री में कहते हैं ना मैक्सिमम लोग फेल होते हैं, तो दैट्स द रीज़न कि बाद में चीज़ें क्लियर नहीं होती। वाशवी नेजी विधि, क्लास के बाद आई वॉन्ट द नोट्स, आई वांट टू सी हाउ मच अटेंटिवली यू आर पार्टिसिपेटिंग। बीच में क्वेश्चन के आंसर्स पूछता हूँ तो तीनों गायब हो जाते हो, एक आंसर नहीं आता है तुम लोगों का क्लास में। एनीवेज, पढ़ो तो अपने लिए, नहीं पढ़ोगे तो अपने लिए ही करोगे नुकसान। नथिंग इज गोइंग टू चेंज फॉर एनीवन। तो C1 इन द स्ट्रेट चेन form is not an asymmetric carbon atom? Asymmetric carbon atom. Okay. Now remember that 99% of the glucose in solution exist in the ring form. Exist in the ring form. You already know कि if suppose I'm considering my body. Now body is made up of water, and even if I'm telling कि glucose in our body is present in the like in a solution form. Why solution? Because it is dissolved in the water that is present in our body. So ultimately the glucose which is present in our body, it is in the ring form. Okay, because if in our body if we are considering glucose, our body is predominantly made up of water. Okay, which means the form of glucose that is present in our body, it is in the form of solution. ग्लूकोज नॉर्मली ऐसे प्रेजेंट नहीं है हमारी बॉडी में. ग्लूकोज इट इज मिक्स्ड विद द बॉडी वाटर एंड इट इज इन द फॉर्म ऑफ अ सोल्यूशन. और सोल्यूशन में ग्लूकोज एग्जिस्ट इन द रिंग फॉर्म. ग्लूकोज एग्जिस्ट इन द रिंग फॉर्म. सो रिमेंबर कि बिकॉज if in our body we are considering glucose, our body is predominantly made up of water. Okay, which means the form of glucose which is present in our body is in solution. Okay, now you already know glucose majority 99% is existing in the ring form. तो ग्लूकोज हमारी बॉडी में मेजॉरिटी इट इज प्रेजेंट इन द रिंग फॉर्म. Okay, majority it is present in the ring form. So you already know, if we just try to draw the structure of glucose in the ring form and try to find the number of asymmetric carbon atoms over here, you already know that is the C5 carbon, it is the C1, then we have C2, C3, C4, and it is attached to C6. It is attached to C6. You already know the first carbon, it will contain H over here and OH over here. Okay, now बच्चे try to see that this carbon over here, this carbon 1, what I am trying to explain कि straight chain में carbon 1 is not an asymmetric carbon, but ring structure में carbon 1 is basically an asymmetric carbon atom. Carbon 1 is basically an asymmetric carbon atom. You can very well see कि इस कार्बन की 4 डिफरेंट वैलेंसीज हैं. एक तो ये हो गया विच इज बॉन्डेड टू द ऑक्सीजन. ओके, एक वैलेंसी ये हो गई OH वाली, एक हो गई ये थर्ड H वाली, और एक ये फोर्थ पूरी की पूरी. ओके, एक ये फोर्थ पूरी की पूरी. तो कार्बन 1 इन रिंग स्ट्रक्चर इट इज हैविंग 4 डिफरेंट वैलेंसीज. सो इन रिंग स्ट्रक्चर, in ring structure, remember carbon 1 is also an asymmetric carbon atom. Carbon 1 is also an asymmetric carbon atom. Carbon 1 is also an asymmetric carbon atom. Okay, so that is about the ring structure. Okay, that is about the ring structure. Yes, sure. नेक्स्ट अगर हम फ्रक्टोज की बात करें, सो यू ऑलरेडी नो, yeah, we have the structure of fructose. You already know it's a 6 carbon compound. Starting from 1 2 3 4 5 6. Okay, the second carbon is bonded to oxygen. The third carbon, you already know, H side hoga, just similar to glucose. Okay, OH will be here, just similar to glucose. So this is the structure of the glucose. Okay, now C1 over here, it cannot be an asymmetric carbon, not an asymmetric carbon. You already know it is not an asymmetric carbon. Okay, carbon atom. Why? Because this hydrogen 2, अब ये CH2OH को मैं इस तरीके से लिख सकता हूँ, H H और OH, तो ये दो वैलेंसी तो सेम ही हो गई ना, तो ये एसिमेट्रिक नहीं हुआ. एसिमेट्रिक के लिए चारों की चारों डिफरेंट होनी चाहिए. एसिमेट्रिक के लिए चारों की चारों डिफरेंट होनी चाहिए. ओके ओके. ओवर हियर व्हाट आई वांटेड टू टेल कि स्ट्रेट चेन में सेकंड कार्बन भी एसिमेट्रिक है. C2 इन स्ट्रेट फॉर्म इट इज नॉट एन एसिमेट्रिक, क्योंकि दो ऑक्सीजन के साथ बॉन्ड बना रहा है ना, दो बॉन्ड सेम हो गए, दो ऑक्सीजन के साथ बॉन्ड बना रहा है. इट इज नॉट एन एसिमेट्रिक carbon atom. It is not an asymmetric carbon atom. Okay, but if we talk about ring structure, then it is asymmetric. You already know we have the ring structure of fructose. Okay, you already know we have carbon 2 over here, carbon 5 over here, carbon 3, carbon 4. Okay, carbon 5 is attached to carbon 6 and carbon 2 is attached to carbon 1, that is CH2OH. Okay, that is CH2OH. Okay, and OH is over here. So now if I just try to relocate the different valencies over here, the first bond you can very well see it is the oxygen. Okay, second you can see it is the other group, that is CH2OH. I'm talking about carbon second. The third is the OH and the fourth one it is this part. So this carbon is basically getting 4 different valencies in the ring structure. So in ring structure the fructose is asymmetric. In ring structure fructose is asymmetric. Carbon. Fructose is asymmetric. Okay. So we'll write this point over here in our notes. Start in ring structure. In ring structure, the aldose and ketose, okay, that is the carbon atom which is having the functional group okay, okay, that is C1 of glucose. ग्लूकोज के कार्बन 1 पे ही CHO ग्रुप होता है. ओके, ग्लूकोज के कार्बन 1 पे ही CHO ग्रुप होता है. और C2 ऑफ फ्रक्टोज के कार्बन 2 पे C डबल बॉन्ड O प्रेजेंट होता है ना, C डबल बॉन्ड O प्रेजेंट होता है और कार्बन 1 पे यहाँ पे CHO ग्रुप प्रेजेंट होता है. तो ये जो फंक्शनल ग्रुप्स प्रेजेंट होते हैं ना रिंग स्ट्रक्चर में, सो बेसिकली दे आर कंसिडर्ड एज asymmetric carbon atom. They are considered as asymmetric carbon atom. Okay, but straight chain की बात करेंगे तो ये asymmetric नहीं होते. In straight chain they are not asymmetric. In ring structure they automatically turn to asymmetric carbon atoms occupied by different 4 valencies. 4 वैलेंसीज डिफरेंट होंगी तो एसिमेट्रिक है, अगर 2 भी मैच कर रही हैं तो एसिमेट्रिक नहीं है, एसिमेट्रिक नहीं है। ओके, नाउ so if you know the number of asymmetrical carbon atoms, if you know the number of asymmetrical carbon atoms, we can calculate the number of structural isomers. We can calculate the number of structural isomers. Okay, if you know the number of asymmetrical carbon atom, we can easily calculate the number of structural isomers. We can easily calculate the number of structural isomers. So you already know, if we are talking about glucose in the ring form, okay, or I'll just write it on the next slide. I will just write it on the next slide. And now you are going to tell me कि ग्लूकोज के रिंग फॉर्म में कितने asymmetrical कार्बन एटम्स होते हैं. आई एम वेटिंग फॉर योर आंसर्स. जस्ट लेट मी नो ग्लूकोज के रिंग फॉर्म में कितने asymmetrical कार्बन एटम्स प्रेजेंट होते हैं. ग्लूकोज के रिंग फॉर्म में हाउ मेनी asymmetrical कार्बन एटम्स आर प्रेजेंट. जस्ट लेट मी नो, so that I will now tell you how to calculate the number of structural isomers. So you already know, if you are talking about the glucose that is present in the ring form, it consists of 5 different carbon atoms. It consists of 5 different carbon atoms. Okay, that is 5 asymmetric carbon atoms. I don't know why you are not answering. I have just spoken कि रिंग फॉर्म में फर्स्ट कार्बन भी asymmetric होता है. Okay, so we have 5 asymmetric carbon atoms. So we have a rule that is called as Liber-Wandhoff rule. Yes Hazira, yes you are right, it is 5. पता नहीं बाकी सिर्फ थम्स अप दिखा रहे हैं, आंसर्स कोई दे नहीं रहा है. Liber-Wandhoff rule, which simply says that number of structural isomers is equal to 2 raised to the power n. Okay, where n denotes the number of asymmetric carbon atom, where n denotes the number of asymmetric carbon atoms, where n denotes the number of asymmetric carbon atoms. So if we are talking about glucose in the ring form, so what will be the number of structural isomers? It will be 2 raised to the power n. And remember, okay, n is basically the number of asymmetrical carbon atoms. In ring form we have 5. We have 5 carbons. Yes, we have 5 carbons. So yeah, the number of structural isomers will be 2 raised to the power 5. It will be 2 into 2 into 2 into 2 into 2. It is 32. So if the question says how many structural isomers of glucose are possible, so it is simply 32 structural isomers of glucose. Structural isomers of glucose possible, basically it is 32 because it consists of 5 asymmetric carbon atoms. It consists of 5 asymmetric carbon atoms. Okay, so that is the number of structural isomers for glucose. Coming on to the next part. Okay, now I have a question to you people and you people will answer. थोड़ा सा दिमाग यूज करना है. How many structural isomers are there in case of glucose? How many structural isomers are there in case of glucose? Yes. Options are 4, 10, 16 and 8. I'm waiting for your answers, everyone. It is 4, 10, 16 and 8. I'm waiting for your answers, everyone. Anyone who would like to answer this particular question कि इसमें आंसर क्या होगा? चलो बेटा, अभी मैंने बोला कि ग्लूकोज रिंग फॉर्म में होता है, तो रिंग फॉर्म में 5 हैं कार्बन एटम्स, तो 2 की पावर 5 करेंगे तो 32, बट ऑप्शन में 32 तो है ही नहीं, ऑप्शन में 32 इज नॉट देयर. Now what we are going to do, we are not considering the ring form, we are considering the straight chain structure. We are considering the straight chain structure, और straight chain में कितने asymmetric carbons होते? 4 carbons are asymmetric, और 2 की पावर अगर हम 4 करेंगे तो you will simply get an answer that is 16. Yes, Hazira, very good, perfect beta. You will simply get an answer that is 16. रोहित परफेक्ट, यस इट इज 16. क्वेश्चन में अगर कुछ भी मेंशन्ड नहीं है, सबसे पहले आपको रिंग फॉर्म के अकॉर्डिंगली कैलकुलेट करना है. अगर रिंग फॉर्म वाला ऑप्शन ही नहीं है तो फिर यू हैव टू मूव ऑन टू द स्ट्रेट चेन, और स्ट्रेट चेन में 4 एसिमेट्रिक कार्बन एटम्स प्रेजेंट होते हैं. रिंग में 5 होते हैं तो 32 हो गया, स्ट्रेट चेन में 4 होते हैं तो इट विल बी 16. इट विल बी 16. यस, इट विल बी 16. Perfect, perfect. So that was all about the number of structural isomers, okay, and the carbons which are asymmetric. Now I'm going to start with the different structural isomers of glucose. Okay, now I'm going to start with the different structural isomers of glucose. We have just now calculated the number of asymmetric carbon atoms. Now I will simply start with the different structural isomers of glucose. Different structural isomers of glucose. Different structural isomers of glucose. So write down, we are going to study 3 types in this. That is the very first one, D and L isomerism. D and L isomerism. Second one, it is the enomerism. And the third one, that is the epimers. That is the epimers. That is the epimers. So these are 3 different structural isomers that we are going to study in case of glucose. One by one we are going to start, and the very first one that we are going to focus now, it is about the D and L isomerism. The D and L isomerism. The D and L isomerism. So remember that what is the difference between the D and the L glucose? What is the difference between the D and the L glucose? Now this is the mirror, and I'm just going to draw this, the structures of glucose. I'll draw the mirror more nicely so that you are more like, okay. So yes, I'm going to draw the D and L isomers of glucose. Okay, so now you already know we have 6 carbons. We have 6 carbons. We will first number all the carbon atoms. And now I will write the functional group. You already know we have the functional group which is present at the first carbon. Okay, the OH group which is present on the right hand side, okay, on the third, fourth and fifth carbon, on the third, fourth and fifth carbon, whereas the OH is also present over here only, OH is also present over here only, and rest hydrogen is over here, that is simply CH2OH. CH2OH को मैंने इस तरीके से बाइफिकेट कर दिया, आप लोग देख के भी लिख सकते हो, वैसे ही लिखा हुआ है, ठीक है, नथिंग मच टू। और इसमें जो हाइड्रोजन होता है यू ऑलरेडी नो कि थर्ड वाले प्लेस का हाइड्रोजन इट इज ऑन द लेफ्ट हैंड साइड, और बाकी सब जगह बैलेंस करने के लिए आई विल जस्ट पुट द हाइड्रोजन एटम्स, सॉरी हाइड्रोक्सिल था, हाइड्रोजन एटम्स हमने इस तरीके से लगा दिया, हमने इस तरीके से लगा दिया। So that is commonly known as the D-glucose. It is commonly known as the D-glucose. Okay, it commonly known as the D-glucose. Now, what do you understand? Okay, by the structural isomerism. Okay, structural isomerism. अब इसी का अगर मैं L form बनाना है, अगर इसी का मुझे L form बनाना है, now what I will do? तो स्ट्रक्चरल आइसोमेरिज्म इन दिस ग्लूकोज, ओके, अगर हम ग्लूकोज की बात कर रहे हैं और हम ग्लूकोज में कह रहे हैं कि हमें स्ट्रक्चरल आइसोमेरिज्म दिखाना है, इन ग्लूकोज हैव टू शो द स्ट्रक्चरल आइसोमेरिज्म, इट सिंपली मीन्स द डिफरेंस इन द ओरिएंटेशन ऑफ हाइड्रोजन एंड हाइड्रोक्सिल ग्रुप. It simply means hydrogen and hydroxyl groups. Okay, तो अगर मुझे सिंपल ये दिखाना है तो first I will draw the structure, that is the glucose, the 6 carbon atoms. Okay, the 6 carbon atoms. The first carbon and the last carbon will remain the same. What will happen in the structural isomerism or the L form of glucose? The H and OH orientation will change. The H and OH orientation will change. In second carbon, you can see the OH is on the right side. Okay, this is the right side, this is the left side. So what will happen when we try to form the L form of glucose? Okay, when we form the when we try to write the L form of the glucose, what will happen? This OH will shift to the left hand side according to my definition, which simply means the difference in the orientation of the hydrogen and hydroxyl groups, which simply means the difference in the orientation of the hydrogen and the hydroxyl groups. Okay, now what will happen? The third place का जो OH left hand side था, इसमें यहाँ पे right hand side आ जाएगा, fourth का OH इस side आ जाएगा, fifth का OH इस side आ जाएगा. Okay, it's just only the second, third, fourth carbon. इनको बस उल्टा करना है, in simple language इनको बस उल्टा करना है, और बाकी सबके हाइड्रोजन भी अपोजिट प्लेसेस पर आ जाएंगे, बाकी सबके हाइड्रोजन भी अपोजिट प्लेसेस पर आ जाएंगे. Okay, so this is the L form of the glucose. This is the L form of the glucose. This is the L form of the glucose, where only the difference is in the orientation of the hydrogen and the hydroxyl groups. Okay, hydroxyl groups. Okay, so I hope you have understood this. I hope you have understood this, guys, today. Yes, I hope you have all understood this particular part. So is there any doubt? I will be like covering the different structural isomerisms tomorrow also. Today I took class of 1 hour. Tomorrow also 1 hour I will teach you about the different structural isomerisms, and then we will start the main topic, that is the metabolism of carbohydrates. Very very important. उसी में से main questions आते हैं, ये सब भी पूछे जाते हैं single liners में. ठीक है, I hope you all understood today's topic, whatever we have discussed up till now. Okay, the oxidation, the different monosaccharides, disaccharides, polysaccharides, the bond formation, the reactions, everything I suppose you all have gone through. And now yes, tomorrow I will discuss that also. Okay, perfect. Okay, चलो हजीरा, perfect, समझ में आ गया. That's like more or less very good.